Hello guys, welcome to our channel eaudemathematica. Okay, so today I want to discuss you about a very interesting problem that is posed by Brilliant Math site. Yes, it is Brilliant Math site. Not only its name is brilliant, but its maths puzzles are also very brilliant. The site information is given in the video's description. I would give you the details and the link. Okay, the link is very easy, www.brilliant.org. okay, so without wasting any more time, just jump into the question. Okay, so come to see what is the question. The question is an integration puzzle with differentiation junk. Okay, so first we discuss about what is the question. So okay, so let me discuss about. So the question is, suppose your g of a, so let me a be any positive real number. Okay, g of a be a function, obviously real valued function. Okay, real valued function for all a belongs to positive real numbers. So be careful, it's positive real numbers. So it is given positive real numbers, but whenever you are solving this, you would see that I think no longer need this kind of criterion. Okay, so let me show you. So first of all, this is, and not only that, it satisfies, and this function satisfies a special property g of a 0 to infinity x e to the power minus x squared over a squared is equals to 0 to infinity cos x. Okay, dx, don't forget to give the dx. Okay, so you can see that this is our equation. Now the question is, you have to find, now on the basis of this mainly you have to find e of say pi to the power 20 plus c to the power 2019 if you like, times g of pi to the 2021 plus say minus 2020. So you have to find this value. As I want to assure you that I have written here some monsters inside G. Okay, as it is so much ridiculous, so much nasty to look, and they are also very monstrous to see. But then whenever you have found this kind of results inside something which is very weird, you will understand that okay, they have no value, that is depending on G. So there will be some identity or something like, yes, that would happen here. You would gradually found that G of A is a constant. By the way, this would be just 1. Whenever they have no special meaning, actually this is just to terrify you. But you find that the product, each one is 1 for all A. So this is also positive numbers, you can see that. And you go, okay, you have to be careful to see that is this a positive number or not. So yeah, it is also a positive number because pi is obviously greater than e and they have less power. So I have assured that don't give this term to this term to, and I don't know what will be bigger. Oh, so that will be a problem. Okay, so don't look up to that. But so far so good, this is okay. Okay, we can check whether that is bigger or not. You can check it by your own. 2020 is this or this. Okay, it's over 2020. You can check this. I don't know, but you can check and let me show in the comment box. Okay, what is bigger? So you can check. But for this, I have been safe. Okay, by doing that, secured. So You can pause the video and let's make a try, or then jump up to the solution. Okay, jump up to the solution. Jump into the solution. This is our required relation that you have to remind, and you can put down in your book, exercise book. I am erasing because I have put it down in my mind. Yeah. So let's try to the solution. So basically, to do this kind of solution, you have to need some basic things. So first of all, a technique, actually a basic technique. The technique is called Feynman differentiation under the integration sign, especially partial differentiation. Actually that was a Leibniz rule, but this is a special rule, a special version of Leibniz rule, particular version. So you know, I think, Feynman technique, how to do, but let's try it. So say, if I am making any mistake or not, or any violation or not, so let me suppose I have done a special kind of form. That means, say I have done b comma x. About doing that, I denote I of b comma x is equals to 0 to infinity. That was the cos of x plus a times e to the minus b times x plus a dx. As you can see that we have this term here, but not this term here. But you can find that if I put I 0 comma x, that will give me the special form that I have. So this is a more generalized form. But why have they done that? So let me partially differentiate I with respect to b, obviously. So I will partially differentiate with respect to b, and that's going to give you this thing. So I'm going to partially differentiate this. That will be partially differentiated, but as the integration is convergent, so you can write it in the sum of the infinite limit, as in the 11 or 12 textbook, you know, Riemann integration actually. If you don't like Riemann integration, you can use your 12 book to express it, and you know the sum is convergent, it is a finite sum, so you can for all 0 to infinity, so for all separate summation, I can make it a partially differentiated. This makes sense. So that partial differentiation would go inside. As for summation, that would work for also integration. So I just put the differentiation inside the summation. So I will do that. But they are all constant to b, but that is not. So nothing will happen, but that would come down below. Obviously with a minus sign, is equal minus b times x plus a. But that is really good for us because we can cancel. So why we have set up like that? So minus comes out, cos x is equal to minus b times this. But what would be the result? So that you also done in the 11 or 12 textbooks this kind of integration. I think 12 textbook, but let's try it. It is not too much hard, so I hope that. So guys, I have seen that. So we have come up here, and then we can come. If you check out your 12 textbook, you can easily solve this kind of. Actually, we have bring out this BA, which is actually independent of x here, and then we integrate. If we integrate this guy, we could find this guy. But that is this. Nice. So far so good. Now what I have to do now, as long as we have this, what we can do? Yes, as long as we have this, we can easily manipulate that as something a little bit. As you can see that this is independent of x, so obviously no longer x is needed. So I can change the variable b with something else variable, say it is x or say it is y, so for convenience. So I can say that I dv dy, say, is equals to minus the integration, and how much the integration could be up to, that would be the matter. So okay, so I find what is my I. If I check what is my I is integration of this, that will be y. I have changed this with y b to the power minus ya by 1 plus y square dy, okay, plus some integration constant. What it would be, I don't care, but you can check it out. But this is actually same as that is here, okay. So that is also I, this is also my I. But whenever I put b to infinity, okay, so what I am putting the b to infinity, so as I am putting b to infinity also over here, that will be 0, as you can see that this tending to 0, actually y, okay, let me, it is b also, again b, to make it clarify also, that is infinity, that means this is 1 by infinity is 0, going to 0 is 0, and b times this, as you can check the L'Hopital, you can take the thing tends to infinity, tends to 0, as b tends to infinity, this tends to 0 by L'Hopital, and this by this, as this tends to infinity, this tends to 0, because no longer is b is here, always constant, this is also 0, this 0, this 0, if force of the c is also 0, okay. So we don't put c over here, but the case is not also too much trickier, but then you can see that I plug BA is equals to some u, so I plug BA is equals to some u. So what happens to this kind of thing to be interchanged with? So say that would be, okay, as you can find our b is 0 to infinity, so I would also plug 0 to infinity, okay, this is also 0 to infinity. This is not an integration, but this kind of differentiation, to come back to the former result, is 0 to infinity, so I also plug this 0 to infinity, the integration, okay. And otherwise it would be not a function, it would be a function after coming out, it will be function of b. But whenever you solve this, you can see that this is, yes, obviously also a function of b, right, but whenever you would plug the limit, it would not be a function of b, then you should not give the limit, that you have to remember. But okay, no matter, but let me show you, because we have plugged this here, what can I do? So let's check it out, what happens. So that would be b is equals to u by a, so good, e to the power minus u, very nice, db is equals to du over a, so good, and b squared is equals to, okay, u squared over a squared plus 1. But once you solve this kind of thing, you would come to the result. Just erasing this part, okay. I have erased this part. You can find that I of b comma x is nothing but something minus of, we're gonna have minus, what we have, u to the power minus u squared plus a squared du. We're all almost set, but where's the grey cheese? Okay, I plug u by a. Okay, no better. That is cool. I want to say, confirm you that we don't need this. But by the way, what we need? Okay, we have to give it some form. So you can see that whenever we have come out the function, this and this is same. No matter, this and this is same. So let me put it b. this and this is same, but whenever I put b is equals to 0 here, so we're gonna have this is actually that I need this function. So I plug b is equals to 0 over here to integrate, but remember I have integrated the sum. Okay, I am integrating the sum from the differential to this. So I have to integrate also this to come to this result from 0 in the limit form, okay, to infinity. Whenever this is infinity, this is 0, so no harm, we can add up to, so we can give here the sign. And now in this kind of form, actually if you, in the previous I have said that there will be a minus, but if you can calculate it, I think I have made a mistake, there would not be a minus. Okay, so you can find that this one is not this one, because I have taken the limit b to 0 to start, that would be limit b tends to 0, obviously positive because up to 0 to this, not on the left side. So this thing is right now is gonna be equal to our this thing. Okay, as I have taken the limit here also, and you can find this. But what was our relation? So you can change this, you can change this to be x again, no matter, because one single variable we are switching. Okay, so what was that in the previously g of a, as you can remember? Okay, yes, this was the relation. And don't forget to give dx, but you can see this and this are equal for all a positive. Oh, okay, positive makes sense because everything is positive in the range. Why this is positive? I have said the positive is no longer needed, but needing some special kind of analysis, because these are all positive, so it is positive no matter. Then this and this are equal, that means z should be equals to 1. Cool. So what inside you put of g, that is equals to 1, and hence that was given 2 to the power 2020 as is there, 2019 as is there, and t to the power 2021 as a given to the 2020. This one is 1, this one is 1, so it is equals to 1, and hence your result is. Thanks for watching. If you love this video, okay, thank you. But I want to share with you something more. Okay, what was that? If you want to get this kind of results, this kind of maths, you can search out www.brilliant.org. the link would be in the description, I have said previously, and also I will give you there a site. Okay, so let's check it out here, my site, where you can find more puzzles like that. So just I am giving you the site in my phone, I am opening that. Okay, so just search on the, you have to just go on the Google bar and you have to search eaudemathematica.com. okay, the link would be in the description. As you have searched, you can find in front of you a page would be open, but net is a little slow, so it's a problem. Okay, so you can go to the menu bar, you can see here my posts, you can tap here and you can find many posts posted by me. Okay, net is slow, so you can search for you, a link would be in the description. So thanks for watching, goodbye.